Hi, boys and girls. Fifth graders, it's time for part 3 of the geometry review for the coming up test, okay? Mr. Buddy's here today to see and learn along with you. Do you think the boys and girls can see that? Let's ask them. Can you see it, boys and girls? I hope so. Okay, let's begin. Part 3 deals with the following concepts, and we're going to make them real easy for you in a minute. Congruent figures, which are figures that are the same shape and size. And if you look down here at this example, these two rectangles, now again, pardon my drawing, but they are supposed to be the same. Even if this one was standing vertically, these two are congruent because they are the same shape and size. Then there are similar figures. Similar figures may not be the same size. They can be the same shape though. For instance, this rectangle and this rectangle are not congruent, but they are similar. In fact, they're so similar, I measured them for you. The width of this one is 4 centimeters. The width of the little one is 2 centimeters. 2 to 4, okay? The length of this one is 12 centimeters. The length of this one is 6. 6 to 12. If you reduce those fractions, you'd have the fraction 1/2. This little rectangle is half the size of this, or we could say this larger rectangle is twice as big as this. They are similar, certainly rectangles, but they are not congruent, are they? They would have to be the same shape and size, okay? Then there's such things as lines of symmetry. A line of symmetry is a line which cuts a figure exactly in half. Here's lines of symmetry on regular polygons, okay? Here's a equilateral triangle. If you were to fold it 3 ways, you'd have 3 lines of symmetry. Here's a perfect square, 4-sided figure. Remember, regular polygons means they have the same size sides. You'd have 4 lines of symmetry. Then I tried to draw for you an octagon, okay? And that's supposed to be a perfect octagon. If you were to fold it, you could fold it 8 different ways and get 8 lines of symmetry. That holds true for regular polygons, okay? If I had a hexagon, perfect hexagon, and I could fold it 6 ways and I'd have 6 lines of symmetry. But lines of symmetry are different when you have irregular polygons. For example, this here is a isosceles triangle. See, my tick marks show that those 2 sides are the same, but they're different than the bottom. You can only fold that 1 way. Here's a rectangle, and this is always a bone of contention to many students. They think it should be like a square and have 4 lines of symmetry. Even though it has 4 sides, remember, it's irregular. It doesn't have the same size sides. This only has 2 lines of symmetry. In other words, you could fold it in half this way or this way. Now, let me show you, just to prove to you, for those of you who think you can fold it diagonally, look what happens when you do. Uh-oh. They don't fold exactly on top of one another, do they? So they're not lines of symmetry. Now, there are some polygons that have 0 lines of symmetry. No matter how I tried to fold this, it would never, ever, one side would never, ever fall completely perfectly over on the other side. Okay, so that's lines of symmetry. Now we're going to talk about, transformations. Okay, transformations is a big word that just means polygons, those figures we've been talking about, can move. They can change positions, okay? And there are 3 kinds of transformations. There's the slide, which is called a translation. I like to call it a slide. Let's say we're starting with this blue square, okay? And I wanted to move it up 3. So from this point, up 3, and then over to the right 3. 1, 2, 3. The yellow square is where it would end up. It just slid from the blue position to the yellow position. That's an example of a slide or a translation. Let's look at this now. We have a blue, supposed to be equilateral triangle, okay? And I want to look at this point right here. It's 1 space away from the vertical line on my quadrant here. If I flip it over, this same point would be 1 space away from the center line. A flip or a mirror image is a reflection. Think of yourself looking in a mirror. You'd get the figure on the opposite side looking back at you. It's a reflection or a flip. Then there's such a thing as a rotation. Okay, let's look at this rectangle for a minute. I can turn it, and in this case, let me show you what would happen. I'm going to take my blue rectangle. See the point where I'm turning it at? It has to have a certain point you're turning at. and it would end up right here. I just made a 90-degree turn, or a quarter turn, because there's 4 quadrants here, a quarter turn rotation, okay? Now there's something called, which was really kind of important, rotational symmetry. Now let's look at this triangle for a minute, okay? How much would I have to turn it if I start here to make it look like it is right now? Now, for example, if I turn it this much, it's not up and down like the original yellow one. It's still not. It's still not. Finally, if I move the triangle to this position, the blue one looks like the same position as the yellow one was, right? This is what they mean when they say, what was the degree of turn? I would take my protractor at this point and measure the angle. Now, I already did this in advance for you. That's a 120-degree turn. I would have to turn this triangle 120 degrees to make it end up in the same position pointing upward as this one, okay? So that's an example of a rotational symmetry, and we say that has rotational symmetry because I can turn it 120 degrees and get it back to where my triangle is, okay? Now, if I turn this one this way, that would be what? 180-degree turn. Wow, another 90-degree. Finally, to get it back into the original position, I'd have to make a complete circle, 360-degree turn, wouldn't I? Okay, so that's rotational symmetry. So remember, transformations of polygons just mean that they can move. They can slide, they can flip, they can turn. Slide is a translation, reflection is a flip, and a rotation is a turn. And that's basically it. You want to wish the boys and girls a good time on their test? Good luck, boys and girls.
Good luck, boys and girls.
I know you'll do a great job.
You'll do a great job.
See you again soon.
See you again soon.
Bye-bye.